Math time!
Hello everyone, today we're going to talk about the 6 trigonometric ratios. Okay, let us identify the 6 trigonometric ratios given a right triangle. So we have here in our illustration, we have triangle A, C, B, where we have here as angle theta, and this angle here, angle C, is our right angle. So let's name first the sides of our triangle ACB. So in this case, opposite to that one, that could be named as side C. And this one, opposite, that would be side A. And lastly, we have here, this could be named as side B. So in this case, that we have side A and side B are the legs of our triangle ACB, while side C is our hypotenuse of triangle ACB because ACB has this angle C as our right angle. So it's opposite to that one, so meaning to say side C is our hypotenuse. Alright, now looking back into our problem here is we are asked to identify the 6 trigonometric ratios. So again and again, we have the primary trigonometric ratios, and these are the sine, cosine, and tangent. So to get the sine theta, so if we would have this angle here as our theta, so sine theta is equal to opposite over hypotenuse. And cosine theta is adjacent over hypotenuse, and tangent theta is equal to opposite over adjacent. Now, how about the other 3 trigonometric ratios, or shall we say the secondary trigonometric ratios? And these are the cosecant theta, which is hypotenuse is over opposite, and secant theta is equal to hypotenuse over adjacent, and we have cotangent theta is equal to adjacent over opposite. And if you try to take a look with this one, if you would have sine theta, that is opposite over hypotenuse, so the secondary one, which is the cosecant, is just a reciprocal. Same thing when you have cosine and secant. So we have adjacent over hypotenuse, and in here hypotenuse over adjacent. Same thing when you do also have tangent, opposite over adjacent. So in our cotangent, that would be adjacent over opposite. Now, our aim here is to identify from this illustration the 6 trigonometric ratios. Where are this one? Okay, so again, side C is now our hypotenuse. Okay, and so since this is the angle that we are referring to, so meaning to say the side opposite, this one is what we call as the adjacent. Okay, so again, this is now the angle, or we call this one as angle B, or the theta is found here. So therefore, opposite to that one, that would be side B. So meaning to say that is our opposite. Alright, so if we will be asked for the sine theta, you would have therefore opposite over hypotenuse. So where is our opposite? That would be B over, okay, where is our hypotenuse? Represented by C. Is that clear? Next, we have adjacent over hypotenuse. So our adjacent here is represented by side A over our hypotenuse is side C. And we have also here opposite over adjacent for the tangent theta. So meaning opposite, that is side B over, which is the A is our adjacent. Alright, so that's how we are going to find the primary trigonometric ratios. How about the secondary? So for the secondary, it's just only a reciprocal. So that is hypotenuse over opposite for the cosecant. So we have here C over B. And second, we have hypotenuse over adjacent. So that is C over A. And for the cotangent, we have adjacent. We have A over the opposite, which is side B. So if you take a look at this one, B over C, C over B. And for the cosecant, cosine rather, A over C. And here, that is C over A. Same thing when we have tangent, B over A. And for the cotangent, that is just an opposite reciprocal, so that is A over B. Is that clear now? Okay. For us to remember properly the equation, let us have a pattern out from this primary trigonometric ratios. We have sine, opposite over hypotenuse. So you would have there the first letter. So we have S, okay, and equals O, which is opposite over hypotenuse. So that is SOH. In here, we could have C, that is adjacent over hypotenuse, meaning A, then H. Okay, this one. We have T, that is opposite over adjacent. So we could have so, ka, towa. That is the mnemonic device that we could use for us to remember properly our equation. So that is for the primary. How about for the secondary? So we have, let's start with the first letter, that is C. That is next, hypotenuse over opposite. Next, we have for the second, we have S. Next is hypotenuse over adjacent. And lastly, we have cotangent. We have C. That is A adjacent over opposite. So that is ko, sha, kao. So for us to remember properly the 6 trigonometric ratio, you would have therefore so, ka, towa, which means sine is equal to opposite over hypotenuse. Ka means cosine is equal to adjacent over hypotenuse, while tangent, we have T, tangent is equal to opposite over adjacent. And for the secondary, we have ko, sha, kao. Is it clear now? So again and again, so, ka, towa. And we have ko, sha, kao. I think that is very easy for us to remember now. Alright? Okay, so in here, our theta is found at angle B. So what if our theta is found at angle A? So just like in this illustration, same illustration, but then our theta is found in here. Okay, so would it still be named as our opposite if we are talking into this angle here? Okay, how about this one? Would that still be named as adjacent? No, it's not anymore named as adjacent or opposite. Rather, since we're talking about the angle here, so therefore, this is the side which is called as adjacent. Okay, if our angle is found in here. So again and again, the side which is consecutive to this angle, or we call that one as our adjacent. So in therefore, this side in here, this could be named as our opposite side. Again and again, our hypotenuse will always have the longest among the three sides. Okay, so we have, this would be still named as hypotenuse. So if we're going to identify our 6 trigonometric ratios, therefore in our illustration here, so we would have therefore sine theta, or we could have sine A, you have opposite over hypotenuse. So meaning our opposite now here is A over, which is C, is our hypotenuse. Is that clear? Okay, well, when you will be asked for the cosine theta or cosine A, you have adjacent over hypotenuse. So where is our adjacent? That is now represented by B. So that is B over C. Is that clear? Okay, for the tangent, that is opposite over adjacent. So opposite of theta is A. So that is A over, what is our adjacent? That is B. Is that clear? And for the cosecant, we have hypotenuse represented by C over opposite. So what is our opposite? That is A. And for the secant, that is hypotenuse over the adjacent. So that is B. And lastly, we have cotangent. We have adjacent, which is represented by B, over, that is opposite, that is A. So same thing, as you can see, C over A. For the primary, that is A over C. And for the cosine, we have B over C, and the reciprocal is C over B. For the tangent, we have A over B. In here, for the cotangent, you would have there B over A. Is that clear now? Okay. So I think that is very, very easy for us to identify. Just always remember that we have this mnemonic device. We have so, ka, tu, wa, and ko, sha, kao.